Okay, hey everybody, thank you guys for coming today. We're super excited to be here and to talk a bit about the art of South of Midnight. My name is... I'm Chad Emond. I'm the lead character artist at Compulsion Games. I joined the team in 2023 as the principal artist. I've worked in the industry professionally since about 2008. Prior to joining the team at Compulsion, I spent time working at Ubisoft and BioWare, as well as a freelance artist for many years. I've worked on franchises such as Splinter Cell, Far Cry, Dragon Age, Tomb Raider, and others. I also serve as a character art mentor for students at Think Tank Training Center, which is a CG VFX school in Canada.
Hi everyone, I'm Paulette Richardson. I'm a principal environment artist at Compulsion. Before joining in 2021, I spent 14 years at Ubisoft Montreal as a texture artist, contributing to titles like Shaun White Snowboarding, Rainbow Six Extraction, and Far Cry 3, 4, and 5. I hold a Bachelor's of Fine Arts in Graphic Design and a Master's of Fine Arts in Animation and Visual Effects. At Compulsion, I helped define the texture style for South of Midnight, managed the material library, and also contributed to level art for areas like Hugging Molly's lab and the Holler interiors.
So just to give you a bit of background on our studio, Compulsion Games was founded in 2009 in Montreal, Canada. We currently have about 90 developers, a mix between on-site and remote. The first two titles we released were Contrast and We Happy Few in 2013 and 2018. In 2018, the team at Compulsion joined Xbox Game Studios before we released our third game, South of Midnight, in 2025, which is why we're all here. So South of Midnight is a third-person action-adventure game. You play as Hazel, and she goes on this journey through a Southern Gothic world, and it's filled with creatures that are inspired by Southern folklore. We released the game on April 8th, 2025. We also have a Switch 2 and PS5 version launching this month on March 31st. Our game was praised for its art style, animation, music, narrative themes, and atmosphere. South of Midnight's artistic pillars focused on mixing Southern Gothic themes with dark fantasy elements, and we presented it with a handcrafted visual style and a stop-motion animation treatment. Today we're going to look at both the environments and the characters of the game. We're going to talk to you a bit about our pipeline and about how we applied these pillars. With that said, we have a trailer we'd love to show you guys, and then Paulette will take over to talk about environments.
I gotta find Mama. It's not safe out there, Hazel.
Careful, dear. That's a wild animal.
Well, we was gonna have to deal with all manners of critters, darling. And try not to get AIDS.
Okay, what crazy thing is about to happen now? She's calling and it's all my fault.
Hazel, please, it isn't safe!
The straightest way to your mama is through there.
Hugging Molly? Give me my mama back!
Come to the stage, my dear. Time for you to pay up. Your mother and I will be waiting for you.
I have to fix this on my own. Make it right.
So I'm going to talk a little bit about texturing the environments and props of South of Midnight. I'm going to go over our team structure, the scope of our game, the visual principles that guided our texture and material work, our process of creating textures using Substance Designer, and our process of creating props using Substance Painter. The environment art team consisted of about 9 to 10 artists. We also had 3 outsourced partners that worked with us. This included Room 8, Onyx, and Agora Studio. Our outsourced partners helped us with prop creation, level art, vegetation, lighting, and cinematics. And I also want to give a special shout out to our tech art team. Without them, we would not have been able to ship our game. This project was truly a collaborative effort and a labor of love from everyone involved. For South of Midnight, we had 14 levels, about 7,000 static mesh assets, and 6,000 environment texture assets. The levels were each named a chapter as if it was in a book. Each biome represents a specific iconic location in the South. The town center represents the real world, and the further you go, the more mythic and exaggerated the world becomes. We wanted each level to have its own unique look and feel, as well as embody the core principles outlined in the art direction. There were 480 tileable texture assets, and there were 208 decals. These texture assets included landscape, man-made, and vegetation textures. We primarily used Substance Designer for all of our tileable textures and trim sheets, and Substance Painter for our props. For the duration of the project, we were using Substance 3D Designer and Substance 3D Painter from 2021, and we also were using Unreal Engine 4. When I joined Compulsion, the team already had a vertical slice and a clear visual direction. They were aiming for a handcrafted look to support the game's stop-motion animation style. Our art director, Whitney Clayton, helped ground this approach by outlining 4 key principles that guided our texture and materials. The first principle was a handcrafted look. Whitney drew inspiration from maquettes and miniature craftsmanship. We also set out to bring that handcrafted sensibility into our texturing workflow, treating every material as if it were built by a maquette artist. We asked ourselves, how would a maquette artist create this, and how do we recreate that digitally? The goal was to make every surface feel tactile, intentional, and rooted in real craft. The second principle was stylized realism. When texturing, we leaned toward realism, but avoided both hyperrealism and overly cartoonish styles. The goal was a more sophisticated, grounded form of stylization, something expressive but still believable. Think stylized yet anchored in reality and not in the direction of Wallace and Gromit or Tim Burton. The third principle was scale and shape. Details were simplified and intentionally chunky with larger bevels that gave prop assets a sense of charm and personality. Everything needed to feel handmade rather than machine perfect. And that philosophy carried directly into the texturing. Lines weren't perfectly straight, and wood grains and patterns were scaled larger than life, as if they'd been crafted in a miniature world. The fourth principle was warm and cool color blending. We avoided flat color for purely grayscale surfaces. Every texture incorporated subtle warm and cool tones to add richness, depth, and a more natural handcrafted feel. On South of Midnight, we aimed for lighting that felt warm, dreamy, surreal, and dramatic. We wanted it to enhance the mythic quality of nature through elements like God rays and large expressive skies. The lighting helped convey the heat, humidity, mood, and narrative intention of each space. To support this look, we relied on baked lighting and used surface light maps and volumetric light maps, though that approach did limit the number of tileable textures we could include in the game. Some solutions we used to fix this problem included screen space, ambient occlusion in Unreal instead of dedicated AO maps, color tinting using RGB masks, texture packing, tracking, and managing textures used in the game. We used Substance Designer to create our tileable textures. To achieve a painted look in Designer, we created our own custom brush strokes. These expressive strokes help reinforce the handcrafted feel and an added sense of age and decay to the assets. I used three main techniques to do this. The first was building my own brushstrokes. This was my first time creating brushstrokes. So I followed a lot of tutorials you'll find for Adobe Substance Designer, like on YouTube. And however, I made a few adjustments to get the look that I wanted. So at first I created a single stroke, and then I used a tile generator or tile sampler to control the direction and flow across the surface. The other two techniques consisted of using two brushstroke nodes created by Marc-Andre Voyer, our technical artist. The first was the brushstroke scatter simple node, which allowed adjustments to rotation, size. However, it only had 2 brush types. I found myself using this node frequently whenever I needed a clean directional brushstroke, especially for things like painted wood. So here's an example of what the painted brushstrokes look like in our game. For the painted wood, I mixed the brushstrokes with the wood grain pattern that I'd made to make it look like it was actually painted on wood. The image on the right shows how that looked once the mask was blended over another bare wood material. The second node was a brushstroke scatter advanced node. And you could use the built-in brush shapes or plug in your own custom brushes. It offered a full control over the stroke behavior, including the amount, scale, orientation, and opacity. The node worked in both grayscale and color modes, making it versatile for many different workflows. It also supported height map input, allowing for scattered brushstrokes to follow the contours of the height information. And another great feature was its compatibility with gradient maps or dynamic gradients, and which allowed you to introduce any colors that you wanted, and then have the node apply them directly to the strokes. A good example of how we used this was on the rock material. I started by building the rock base. For the base color, I made several brushstrokes patterns using the brushstroke scatter advanced node. I wanted the strokes to follow the natural flow you see in real stone, so I warped them to match the surface direction. We also wanted larger wash-like areas mixed with a few distinct shapes. To achieve that, I created the shapes first in the brushstroke node, and then I ran them through a slope blur using the rock height map. This gave everything a consistent hand-painted look and helped to blend smoothly across the surface. After that, we blended all the different brushstrokes together and mixed them back into the rock base to add more color variation. I also created a few additional brushstroke nodes and used their masks to introduce more color where it was needed. I also generated masks from the rock base itself, which allowed me to add more color to specific areas and to build up a more natural layered result. So here's 2 examples of the rock, one without the brushstrokes and one with them. You can see the difference, even though it's subtle, between the 2 different versions. The one on the right feels much richer and has noticeably more detail overall. So this is what the final material looked like. Additionally, when I created the brushstrokes, I also added the brushstrokes to the normal as well. However, very lightly as to not override the shape of the rock. Another way we added a handcrafted look to our materials is through trim sheets. We had a universal layout for our trim sheets. We made them from each material type. This includes wood, concrete, and metal. And for this presentation, I'll just show you the wood as an example. To create our trim sheets, again, our technical artist, Marc-Andre Voyer, built a trim sheet builder node in Substance 3D Designer. It allowed us to add any number of trim pieces. You could adjust their size and position, control the bevel intensity and the smoothing, which be between rectangular and circular shapes, and enable infinite horizontal tiling. This tool could also output a trim sheet mask, and this became the foundation for all of our trim sheet work. Once the trim layout is set, I used a warp and a slope blur to break up the edges so that they didn't feel too straight or uniform. I then blended an existing wood material into the trim sheet normal and the height maps, but first I would warp them so they would follow the trim layout. Because our RHM textures packed roughness, height, and metallic together, I split the channels with an RGB split and warped each one, and then I recombined them. I apply the same process to the normal map, using a normal combine to merge the trim sheet normals with the wood normals cleanly. So here's the wood before, with the material I made before we added the trim sheet to it. And we use this workflow primarily for wood or metal beams, window frames, and props. So now I'm going to talk a little bit about our material setup in Unreal. Our material supported up to 4 layers. Each one could be blended using height blending RGB masks or a combination of both. Every layer included its own normal, height, and RHM map, and we could also apply a color tint per layer. On top of that, we had controls for opacity, height, intensity, and contrast, giving us a lot of flexibility in how the materials interacted. A good example of this approach is in the corrugated metal that we created for the game. I created 3 versions of rusted metal, a bare metal, and a painted metal, each with its own set of texture maps. We aimed for a hand-painted look, so the surfaces have visible paint thickness, and even the bare metal carries subtle paint qualities. The painted corrugated metal is also color tintable, but we avoided making it fully grayscale or white to preserve the warm and cool color variation that gives the material its character. Here's what the material looks like with all the layers blended. And the following images show what it looks like in game with the color tinting and the vertex painting. So we kind of used it wherever we could, on the walls and on the roof, and even on some pickups that you'd see in the game. Another good example of incorporating a handcrafted look into our textures was Two-Toe Tom's belly interior. For this texture and model, we had collaborated with Room 8, our outsourcing partner. Two-Toe Tom's belly was a section of the Two-Toe Tom arena fight. Two-Toe Tom swallows Hazel's mobile home, and later Hazel confronts him, and then he swallows her, and then Hazel must navigate the space to escape. So this was the first iteration of Two-Toe Tom's stomach wall, and it leaned too far into a flesh-like look. We wanted to push the design in a more handcrafted direction, and that's when our art director suggested that the walls should be made out of wet yarn. The second iteration ended up looking too much like rope, and it still didn't feel like yarn. It was also too contrasted and missing the warm and cool color variation that we were aiming for. So it didn't quite capture the look that we wanted. After we provided additional reference and we went through a few more iterations, we eventually arrived at a yarn-like texture that had the warm and cool color blending and the subtle thread detail we were aiming for, and also the amount of contrast and a somewhat flesh-like look. So I'm going to walk you through the process of creating this texture. The artist began by building the individual thread pieces. They created 2 distinct thread shapes, blended them together, and then added a layer of loose fibers on top. That combined thread was then warped and fed into a tile sampler, which generated the base layer for the overall thread pattern. Some additional thread shapes were created to suggest loose fibers, and these were blended on top of the base thread shapes. They also served as a color mask to introduce more variation throughout the threads. All of these layers were then blended together to create the final normal map, We also added an extra pass to introduce subtle lumpiness in the threads, giving the surface more depth and organic variation. For the color map, we use masks derived from the height maps to drive the color variation you see in the texture. We also use gradient maps and uniform color nodes, levels, and blends to get the final diffuse. In order to see more of the thread detail, I added an additional high pass from the normal and adjusted the levels on it. In Two-Toe Tom's Belly, we also had subsurface scattering in the material. These are a few of the masks generated from Substance Painter, created from the model that we use for the subsurface scattering effect. So this is what the final textures look like in-game. And these textures combined with the thread decals form the complete interior look of Two-Toe Tom's Belly. For the game's props, we looked at how real stop-motion maquettes are made and then reverse engineered that process in 3D. We figured out the scale of the maquettes as if they existed in the real world, which helped guide their level of detail, material choices, and overall style. This approach gave artists plenty of room to be creative, and it was totally fine if assets didn't match perfectly. That bit of variation and imperfection helped sell the handmade feel. Small props were created using a combination of hand-painted unique textures, trim sheets, RGB masks, and tileable textures. The props you see here were modeled and textured by Luca Grillet. To start, we modeled a high poly version of our props in ZBrush and modeled a low poly version in Blender. Then we used Substance Painter for baking and texturing. We baked out the texture maps first. Using Substance Painter, we used a combination of hand painting and the oil paint filter to create the surface of the props. This gave the props the handcrafted feeling that we wanted. We also used a top-down gradient edge wear mask for wear and tear and an AO for dirt. For vehicles, we used similar methods, but we also used trim sheets and RGB masks for the color tinting. So for our large props, we used a different process. Some of our large prop assets were 3 to 4 times as large as Hazel. In order to preserve the pixel density, we use RGB masks and tileable textures. This also helped us to reduce the number of textures needed to create these assets. To show our process, I'm going to focus on the Tasty Pig statue, which was modeled by Dylan Abernathy. We created our own smart filter for a RGB mask in Painter. The red channel was primarily for edge wear, the green channel was for additional hand-painted layers, and the blue channel used the AO and cavity maps to apply dirt and additional wear and tear. We used tileable textures when we used this method of texturing along with the mesh bake normal. Along with the edge wear details, the RGB masks also contained discoloration and paint details that we wanted to have on the surface. The entire pig statue had one RGB mask except for the eyes. The eyes were a unique texture. The RGB mask was another way to create the handcrafted look that we wanted for the props. The statue used only one tiled texture set. Since the diffuse was color tintable, we could get a lot of reuse out of this texture. It wasn't just used on the statue, but we also used it throughout the entire game. So here was the Tasty Pig statue. Here's what the Tasty Pig statue looked like in game. You can see the subtle color variation across the surface and the tinting applied using the same material, demonstrating how flexible the texture setup was. We also used Substance Painter to create the building kits. We used the same process that we use for large props. All of the swamp shacks you see in the game used the plank kit built by Emmanuel Lauzon. Emmanuel authored an RGB mask that drives the look of the wood. The model and the UVs were created in Blender, and the mask was then generated in Substance Painter using an RGB smart filter. Each kit piece relies on the same set of old wood-based textures with the mask controlling the variation and the appearance. So this is what the kit looked like. These kit pieces could be put together in a variety of ways to make different swamp shacks. And so here's an example of the different shack buildings that we were able to build out of that one kit. The kit was used for both exteriors and interiors. And as you can see here, the color tinting could change to anything that was desired. The same base wood textures were reused across all of the abandoned areas of the game, but each architectural kit used its own RGB mask. This allowed us to save memory while maintaining a strong visual variety throughout the environments. And that covers my part of the presentation and the environment texturing workflow of South of Midnight. And with that, I'll pass the presentation over to Chad.
Okay, so I'm going to talk a bit about our character production process on South of Midnight. I'll touch a bit on our goals for the handcrafted art style, how we approach the process. I'll take you through our character pipeline and just highlight a few things we learned along the way. I'll also show how we used ZBrush and Substance Painter to help achieve our handcrafted look. So first, I just wanted to talk about the team that we had on the project that helped make it a reality. On Midnight, we had a team of about 4 character artists over the course of the project. Myself and Francesco Baldini joined in 2023, about 2 years before we shipped. I also wanted to acknowledge Rodrigue Pralier and Fabio Henrique, who were on the project before we joined and who helped create many of our characters. We also had great outsourcing partners in Chaos Masons, Agora Studio, and Roommate Studio. They helped us create all of our hair and animals, as well as some of our characters. To bring Hazel's story to life, we had to build a huge range of characters. We had our main cast, like Hazel, Lacey, Bunny Flood, as well as a ton of secondary characters that Hazel meets along her journey. The team also created several epic-sized creatures inspired from Southern folklore, like Two-Toed Tom, which you saw in the trailer, or Huggy Molly, the unsettling spider-like creature. Some of these creatures also serve as boss encounters during Hazel's adventure. We also had several unique enemy archetypes called haints, which in the lore of our game are these physical manifestations of trauma. They look like these twisted, dark, woven entities. They're covered in corruption, and they all had an entirely unique silhouette and design. And then to represent the South, we also populated the world with dozens of different animal species. In total, the team created over 100 unique characters and creatures for the game, each with the same handcrafted attention to detail. At the start of the project, there were a couple big questions the team needed to answer. First was, how do we push the stylization of our characters, but ensure they still fit within our Southern Gothic world and story? We didn't want our characters to feel goofy or silly. They needed to feel believable and fit the tone of our story. And then the second was, how do we make our characters feel handcrafted? And what does that even mean in our game for something to be handcrafted? For the stylization, we had a lot of references, but one that we kept coming back to was J.C. Leyendecker. Leyendecker was a prominent artist in the early 1900s, and the figures he drew had this really interesting, elegant, exaggerated realism. They had strong silhouettes, angular features, asymmetry, but they still felt grounded. And this type of stylized realism served as a touch point for the team as we designed and created the look of our characters. When we were looking at how to give our characters that handcrafted feel, we were really inspired by maquettes and puppets. If you look at clay maquettes, they have all kinds of imperfections on the surface. There's subtle mistakes, rake marks, thumbprints, asymmetry. You can almost feel the real world tools that were used as they made the character. This was key for us as we move forward. And then in terms of scale, we tried to imagine our characters as if they were 13 inches tall, made by real maquette artists in the real world. And that kind of helped us determine how much detail we could put into our characters. And then everything had to also have an organic touch to it, as if it was made by hand. Our team visited Clyde Henry Productions, which is an award-winning stop-motion animation studio in Montreal, Canada. That access really inspired the team, and it gave them a lot of great references for how we could build our characters. We gained a lot of insight into their workflow, how they built things in the real world, and we were able to reverse engineer some of that process of making things by hand and translate it into the digital medium. Something really cool is that that collaboration came full circle. Clyde Henry ended up making the stop-motion intro to our game, which plays when you first boot up the game. The whole thing's available on YouTube. I'd encourage you guys to check it out if you're interested. So although we had a pretty unique art style for our characters, I think our pipeline was pretty straightforward in a lot of ways. We always started with a basic blockout in ZBrush, which helped us to solve early design challenges. We then pushed forward with our high poly sculpts, where we added in all our handcrafted elements, which I'll show you in a bit. And then all of our game-ready models were created and unwrapped in Maya. All our characters were primarily baked in Marmoset Toolbag, but we also used Substance Painter in some cases. As Paulette said, we had an older version of Substance, so we didn't have any of the new baking tools, especially the ones they showed off today, which look great. But having that gave us access to things like skew and cage painting for characters that had a bit more complex baking setups. All of our textures were done in Substance Painter. Once we had a concept, the first step was always a blockout. Typically, we did this all in ZBrush just to allow for a really quick iteration. Starting off with a really simple, quick blockout can help you identify design, rigging, and animation issues early on, and it's something you can do in a day or so. When creating our blockouts, we didn't care about details if the model looked pretty. All that mattered was establishing your primary forms, your proportions, and the general silhouette of the character. During this stage, it's super important to just assume that things will change. You don't want to get too attached. It's much better that they change now than after you've been sculpting something for 2 weeks and you get really attached to it. So this is one of the characters I worked on, Rue. This is a concept by our wonderful artist, Joao Brigado. And it's a pretty common example of the level of detail we got from our concept team. So on the left is my first pass, maybe a day or so of work just blocking out the basic forms. I just try to quickly establish the silhouette, proportions, basic shapes. Again, I'm just treating it basically as a 3D sketch. It's okay if it looks ugly. It's just about getting something in place that represents the character. You're going to continue to iterate on it during the process. Once I had that finished, I would pass it to our technical animation team to address any concerns they had about the design or how it may impact the rest of the pipeline down the road. Sometimes they'll give me notes, which I would address at that stage, or maybe it's just things I need to keep in mind for later when I'm doing the low poly for later on. On the right is a feedback pass that I got from our art director, Whitney Clayton, which highlighted some of the elements we wanted to adjust in the design. Some of them, like opening the jacket or changing the scarf from the concept, would have been a lot more challenging if I had moved too far forward in the modeling process, but since it was just a 3D sketch, it was super easy to adjust and then move on with confidence. And this is the final high poly model that turned out for him. So talking about sculpting, we knew that to sell our handcrafted feel, we needed to replicate specific elements from our references in our sculpts. First, we needed to have those grounded, stylized proportions that we saw in our Leyendecker references to help ground the characters in our world, ensure they felt believable, but we still wanted them to feel unique. Second, we also wanted to feel the tools used in the character. This meant including elements like hard planes, rake marks, smudges, thumbprints. And then finally, we had to have imperfections to help sell that organic, handmade quality of our characters. Nothing made by hand is perfect, and those small imperfections can make all the difference. So here's some of our face sculpts. You have left, right, Itchy, Laurent, and Bunny Flood. You'll see a lot of that exaggeration I was talking about from our early references. There's exaggerated proportions, there's sharp planes, tool marks, asymmetry, imperfections, but there's still a level of groundedness and believability that we wanted for our story. We didn't really have like a specific proportion guideline for our faces. We wanted to kind of feel it out based on the character. We didn't want them to feel like caricatures, but we did want them to reflect their personality. Originally, we put more asymmetry in our faces, but we ended up needing to pull that back a little bit to help our animation and rigging teams, especially in areas like eyes and the mouth. So we tried to think like a real sculptor, what tools they might use to get the forms and the shapes that they wanted. The vast majority of our handcrafted effect was done with standard ZBrush brushes, things like Trim Dynamic, H-Polish, Rake Brush. Having really good references is super key for this stage, so in our case, having lots of references of real clay figures, especially ones that were unfinished, so you could kind of see the construction process. For some specific clay effects, like layered clay or flakes, we did use some brushes that were made by Pablo Munez Gomez, which helped a lot. And then just another example of a finished sculpt. For all of our creatures, we wanted to implement that same handcrafted feel. You'll see a lot of the same exaggerated forms, tool marks, imperfections. This kind of helped us ensure a consistent quality between all of our characters and creatures in our world. For many of our creatures, the handcrafted treatment also meant replicating other materials, imagining how these figures might be created in the real world. In the case of Huggy Molly, we imagined her as a handmade puppet. She's covered in pieces of old tattered cloth. Another example is Rugru, who in our game is this imposing bird-like creature. If you look at his design, there are elements that have the same clay-like skin treatment, but if you look at his actual wings, they're made to look more like handmade woven material. So our designs weren't always about like replicating clay figures specifically. It was more about just being inspired by handcrafted maquettes and puppets and applying that mindset to the creatures and characters of our world as we made and designed them. And then it doesn't get more handcrafted than the lovable crouton, who's just a literal puppet come to life. Okay, so I'm going to talk now about how we use Substance Painter on the project. We'll talk a bit about our approach to texturing skin, clothing, and then how we utilize Painter to really have a good production-friendly, non-destructive workflow. So Substance Painter was our primary texturing tool for the project. We textured all of our characters and creatures, and we also used it to support our visual effects teams. The non-destructive workflow was super valuable in our production. It made things much more flexible. We heavily utilized layers, masks, anchor points, procedural textures, all the great stuff in Substance. For texturing our skin, we weren't using any scans. Everything was textured by hand. We start with a simple flat color base, paint in some subtle ambient occlusion just to establish the general skin tone and forms. We then add in the general color zones of the face, just ensuring we reflected the warmer and cooler skin tones. From there, we kept refining, adding in more hand-painted details, trying to match our concept as best we could. We also would be adding in roughness variation on various layers to make the skin feel more alive and interesting as we went through the process. Our shader setup was pretty simple. We had a base color, a normal map, and something we called an RSF map, which was basically our roughness map and a subsurface mask to control where we wanted the subsurface scattering to be applied. We also had a Fresnel mask in there, but we didn't end up using it much. We ended up controlling it more through our shader. One of the things we found during our texturing process was that a lot of the handcrafted elements that we added to our sculpt got lost along the way. So we needed a way to kind of bring back some of those handcrafted tool marks and details that we put in. One of the ways we did that was by creating a custom mask using our baked curvature map. So we would take our curvature map and invert it, and we were able then to isolate a lot of those details that came out of our high poly. We used then custom paint layers just to edit the mask construction. You could go in there and use different filters and paint layers and blur effects just to control the effect to make sure it was exactly what you wanted. It was a little bit different on every character. But doing that allowed us to basically bring all those crunchy handcrafted details back from our original sculpt. We basically just used that mask, applied it to a fill layer with the value blending mode, and we affected both our color and our roughness channels to bring back a lot of those handcrafted elements. We also relied on Painter to help us create masks for all of our VFX, visual effects on a lot of our creatures. So one example is the corruption you'll see on all of our Haint enemies. For this, we just created a layer at the bottom of our stack with the color ID that we baked out of our high poly. Then we added an anchor point so we could reference that mask anywhere else in the stack. This also meant it was non-destructive, so at any time if there was a direction change, we could go back and alter where that emissive was really easily, and it would update the rest of our stack as needed. For just the emissive part of it, it was super easy because we could just use the mask as is just by referencing the anchor point. But we also wanted to have more finer control over the pulsating effect of the corruption. So in Unreal, we were using world position offset to control the pulsating effect. And we wanted to feather it out so that it was more concentrated in the center of each pustule. We could have painted this by hand, but that would have taken a lot of time, and nobody wants to do that. So since we were using the anchor points, it was super easy to do procedurally with Painter. All we needed to do was create a new fill layer, reference the same anchor point that we created earlier, and use the mask outline filter, which basically just isolated the edges of every pustule for us. And then we could have fine control over each pustule and how much that mask was working. All that was then fed into our Unreal shader, where we had some initial controls for the color and the intensity of the effect. Because we set this up in a non-destructive way using anchor points, it allowed us to save a lot of time then replicating that to the rest of the haints. All we needed to do was save that layer setup as a smart material, and then we could basically just drag and drop it to all the other creatures, and then just export their unique textures, and everything was done. So it saved us a lot of time. So I'm going to roll some videos now just showing the jacket on Rue, just going through the texturing process on clothing. Most of our characters had a few texture sets for their outfits, along with unique texture sets for their face and hair. The amount needed really depended on the character. Whenever I'm building up my textures, I try to work big to small. I focused first just on getting large volumes of color, using basic layers and masks to build up a base and add some basic color variation. I try to work with fill layers and masks whenever possible, which allows me to easily change the textures based on feedback or direction changes. When I'm building up my layers, I usually like to start with some sort of procedural texture or mask. I'll then add paint layers to the mask construction to add hand-authored details. Generally, I've found you get the best results when you combine procedural and hand-authored effects. This approach can also help to remove some of that procedural look that you get sometimes and get something that feels more unique and handcrafted in our case. Rue's clothing also had this really intricate woven pattern design I needed to create. The concept was not entirely defined, so I decided to do it inside Painter instead of adding it to the sculpt, just to allow for more flexibility if there were direction changes. To build this pattern, I created a base mask, which would define just the general shape of the pattern, but kind of ignored all the color information. I built this up with several custom paint layers, as you can see, using a custom alpha with the Lazy Mouse tool. We didn't have any of those fancy new curve tools that we have now. There's some areas where it's not perfectly even because I was doing it by hand, but it actually kind of worked out because of our handcrafted approach, because imperfections are kind of part of the direction. If at any time I needed to edit or change this base mask, all I had to do was add a paint layer to the mask construction and adjust as needed. Once I built this base mask up, all I had to do was create an anchor point at the top of the mask, and now I could reference this mask in future layers where I could add in all my color and height information. For the color, again, I created fill layers with a mask, and I used different procedurals to create volumes of color information. I wanted to confine this to the pattern area, so I just put them all in a folder and masked the entire folder using the pattern anchor point as the fill layer, basically just acting as a clipping mask. Now within that folder, I could create layers as I wanted, using different procedurals to create different color variation, and everything was going to be confined to that original mask. This workflow also allowed me to easily make changes to the colors of the pattern or control the placement as I needed without affecting the original pattern layout. If I needed to alter my original pattern design, I could just go back to that original mask, knowing that all my procedural color layers would adapt to the new pattern automatically. All I had to do was go down, edit that original mask, and that anchor point would update everything automatically for me. I also wanted to add a height effect to the pattern. So again, I was able to reference that same pattern anchor point mask that I set up before, using that as the base just to add height. And then once again, I was able to use the mask outline filter to select the edges of all that mask to create raised edges on the sides, to raise the edges on the side of the pattern. And then we added some flowers and stuff to the rest of the pattern with similar effect. We just had to change the height blending mode to ensure it appeared on top of the rest of the pattern. And that's it for my section. I'm going to pass it back to Paulette, who's got some final words just to wrap things up.
So working on South of Midnight was an incredibly rewarding and collaborative experience. It was a passion project for our team. We hope this presentation gave you some insight into our creative process, and you're able to take away something interesting that you can use in your own projects. And that's all we have for today. Thank you for joining us, and we'll be happy to take some questions. People.
Oh. blasted by the light.
Ooh, yeah.
Hello.
Hi.
Hello.
I had a question about height maps in Unreal Engine. So I've always been told that height maps like kill performance in Unreal Engine. And so I was wondering if you guys took any measures to make sure that it didn't ruin performance at all.
We did. We didn't use parallax a lot. We had height maps mostly just for material blending between the different layers. We had some parallax, but because we were shipping on two versions of the Xbox console, it was turned off for like the Xbox Series S, I believe, and then the Xbox Series X, it was turned on. I believe that was what we came up with. But it does use a lot of memory, so you have to be, when you do use it, you have to be frugal about where you use it. So I think for us, it was primarily in some decals that we had, and I'm not sure in terms of any other place, but that was for us.
Thank you.
No problem.
You have a question?
Hi, I'm Eureka Yulin, and I'm a material artist, and now I'm working on a Tim Burton-style environment work. And my question is, when blending material on environment assets, how do you usually decide between vertex painting or texture painting mask? And if you rely on vertex painting, how do you plan a certain vertex density on it?
I'm sorry, I couldn't really hear you too good.
Sorry, let me ask again. How do you usually decide between vertex painting and texture painting in Unreal?
Oh, like you talk like vertex painting or using a unique texture? Is that what you speak?
Yeah, that's what.
So for us, it depended on the size of the object. So for all our props, the smaller props, we use individual unique texture maps. And then for like larger assets that were really big, because we want to preserve the textile density, we use tileable textures, and that was material layering. Sometimes some of our props, because they had color tinting, we were using a mask. So we might have like material layers for that, just so we could, like one layer would just adjust the color based on like the RGB mask, I guess. So like, yeah.
Since it's like in Unreal now, is there 2 or 3 maybe texture blending method, like the texture paint or the vertex paint? It's 2 different workflow. Yeah. And so you choose the vertex one, right?
Yeah, we chose the vertex one for us. So.
And do you how to plan the certain vertex density for the big giant work or something, some building things like?
Okay, like how do we decide on that?
Decide the vertex density.
Okay.
Yeah.
Because I'm not sure if I understand what you're asking. But we can talk about it after, I think, so no worries.
Question?
Hi, you mentioned a little bit how you had like modular pieces for making your buildings in the game. And I was wondering if you could maybe go into a little bit more like what your process was for figuring out all those pieces, especially like working with level designers. How did you work with level designers to figure out all the pieces you need to make the stuff you wanted in that game?
So we started out, we block out our buildings, we use blockouts first. But for, let's say, the shacks that I showed, that was part of our, I guess, vertical slice, or not vertical slice, but a pre-production that we did. And so the idea there was to have like model individual planks and then build it. But I think the artist who did it, he blocked out each section so you know what you're gonna make and what you would need for that. And then he went and produced it. So that's usually what it is. Even like with outsourcing, we would block out, let's say like the steamboat that we had in the game. That was all blocked out in-house and just kind of, so we would know what we would need for the kit pieces, and then we sent it off and had them build it. So I hope it helps.
Yeah, that's awesome. Thank you.
Okay.
Question?
Yeah, this is kind of a general question, but how do you just make good-looking stylized hair like we see for the characters in this?
How do you make good-looking stylized hair?
Yeah.
Painfully. Nobody likes making hair. Well, some people do. I don't know if there's like a trick to it. A lot of it's going to be like in your shader, depending on how you're stylizing it. A lot of it could be just spending more time in the actual hair textures that you're making, So generally, like to make hair that looks good, you want to have like different levels of density. So have a nice gradient from the most dense to the least dense. But it really does depend on like how you're stylizing the hair, because hair in like Arcane is very different than another project.
Hi, I just had some questions about like your designer process for making materials. One was your like custom tools specifically for the paintbrush scatter. Did it have any limitations in development, such as maybe being repetitive on like large instances of like using like large usage cases, like big props?
Not for me. Well, it is, but we would use like the masking to kind of hide that a bit. And like if you, for example, like the rocks, that was like triplanar projection, and then we'd had a mask that was RGB mask that would drive like the edge wear, and then you had dirt and all of that, and that kind of hid a little bit of that tiling. But if you were on let's say a building or something of that nature, we had to figure out where it was just a flat surface. We had to figure out a slightly different process. But for like large statues, it was fine because when you're the player, you're like really, you're kind of not paying too much attention to that. So it was okay. You didn't really see too much repetitiveness.
Yeah, I was going to then follow up with, for your large scale props, you said that like your process was that you would use like the same material, but through the RGB masking, you would create like visual variation like color, correct? Did that ever have any issues with repetition, or did those like minor color variations and such just hide them entirely?
It was fine because we used, it didn't really see it too much from what we were doing. And then also because the texture itself, it was like a light layer of like the color that was on it. The color tinting that we used on top of that also kind of hid that for like the large props. So like, let's say for the pig statue, we had blue shoes. Then you had the pig skin, which was pink. Then you had the white apron. Because the color was different, it was fine. And then there was like a breakup in terms of like the vertex, painting, or sorry, not vertex painting, but the RGB mask in terms of like, if within our layer system, you might have exposed concrete or the paint layers, so that helped to hide a lot of that. So.
Thank you.
No problem.
Hi. First of all, thanks so much for exposing so much of your process like that. It was really, really wonderful to see. My question's about the character art pipeline. I noticed that you said you used a curvature map to pull the sculpted detail back into the texture. Is there any reason why you opted for a curvature map over just using something like a convex map? I know that Toolbag paints that out natively, and I was wondering if there was just something specific about the curvature map that you decided to use.
The curvature map is nice because you can, like in Substance, you can choose whether you want your edges or your cavities. So it's kind of like just a 2-in-1. So it's kind of just a convenience.
Okay, that makes sense.
It's more than that than anything else.
Okay, that makes total sense. Thank you.
Yeah.
Okay. Hi, my name is Imani, and just really quickly, thank you so much for speaking as just like an inspiring person getting into 3D modeling. This was really informative.
Cool.
But my question was, because earlier you guys mentioned like purposely making like the imperfections within the model so it's more accurate to like if you made it like in sculpturing. So then I wanted to know more so about like how exactly do you go about making those imperfections? Like do you guys just like wing it, or like what's the intentions when you do make them?
Do you want to answer that one?
Yeah, so like I think whenever you're making characters, I'll speak for characters, like you always try and make up like a story in your head as you're making the character, what that character has been through. So it's kind of the same process where, I'm sculpting a face, I'll be like, oh, what if, my hand slipped and I sliced the corner with like the slice brush. And then I just put like a gash in the model. I use like standard tools in ZBrush, like Dam Standard or like the slice tool, really basic stuff like that. But it's more like creating those stories and thinking of the storytelling that you're putting into the model. So adding in thumbprints where maybe the artist like smudged the skin to like smooth it down, stuff like that.
Oh, okay. Thank you.
Hi.
Hello. Also kind of like picking back off of that particular question as well. My question is that again, you guys emphasized it throughout the entire process, the importance of asymmetry within your design to match that vision, the artistic vision. My question is like, were there any particular like issues that you may have ran into that could have been like, easier to implement had you had any type of symmetry? Maybe during like for retopologizing or like for UV mapping, that sort of thing?
I mean, definitely, yeah. So like I was saying, like originally we had a lot more asymmetry in our faces. Like we almost had more of the character expression baked in. Mm-hmm. But we ended up running into issues with animation and rigging, and it also just makes it a lot longer on that side of the pipeline when the character is super asymmetrical. So we ended up pulling some of those back, and we kind of limited the asymmetry to other areas that don't deform as much.
Okay. Gotcha.
Generally, like the proportions of our characters, like the arms and the legs, were fairly symmetrical, so you wouldn't necessarily have to, you could still use symmetry to speed up the process. But a lot of the asymmetrical details came from like the sculpt and the texture, where you could kind of put that in and it's not going to affect the pipeline as much.
Gotcha. Thank you.
Hi, I just want to say right out the gate that you guys are seriously incredible, and thank you so much for taking your time to give us this talk. I'm a student environment artist right now, and I feel like in Unreal, I keep running into the same issue with specularity, and how for semi-stylized or selectively stylized games, specularity often interferes with color maps. And I wanted to know how you guys use or don't use specularity in your textures.
So I think for us, it was like built into the material. So it was just like a slider that we had. Our lighting artist was really the one who was more, I think we set the value at 0.5, but I'm not sure, like I can't really remember off the top of my head if we had, I don't think we had like a specular mask. I know we didn't have specular mask, but I'm not sure if we put something in Unreal to like really control how much we were getting. But I know we could adjust it with a slider sometimes. Generally the value is 0.5 or maybe a little less. We didn't always keep like the same value throughout because it depended on the roughness of the asset and like also just the asset itself and the materials themselves. So like terrain, it might have, I think we had to lower it quite a lot. Like I think it was like 0.1 or maybe less than that. So I don't know if that helps, Cindy.
No, that does. Thank you so much.
Yeah. But it's just like, I think it just depends. I say work with it till you get something you like. That's generally how I look at things.
Okay, thank you.
No problem.
Thanks, everybody.
Thank you.